Alright, welcome back to the AI Research Roundup. I am your host, Alex. Today we're looking at a paper that's been trending, called DraftAttention, Fast Video Diffusion via Low-Resolution Attention Guidance. So, the big problem with high-quality video generation models, like diffusion transformers, is that they are incredibly slow. Generating just a few seconds of video can take minutes, mostly because of a process called attention, which is how the model decides which parts of the video to focus on. This paper introduces a clever, training-free fix. It creates a fast, low-resolution draft of the attention to guide a more efficient computation on the full video, achieving up to 1.75 times speedup on GPUs. Now, before we dive into the details, this method works on what are called diffusion transformers. These are powerful models that generate video by starting with pure noise and then step-by-step, refining it into a clear image, using an architecture that's great at understanding sequences. The key slowdown comes from the attention mechanism, which is how the model weighs the importance of different parts of the video. And if you want to try their solution, the authors have shared the code. Their repository has a great quick start guide and video generation scripts, and the core DraftAttention file is designed as a simple plug-and-play module. And to really hammer home just how much of a bottleneck this attention mechanism is, let's look at this first figure. It breaks down the computational cost for generating a 720p video. This cost is measured in what are called flops, or floating point operations per second, which is basically just a count of the total calculations the computer has to do. We see three pie charts here for an 8-second, a 16-second, and a 32-second video. That huge blue slice in each chart is the attention part. And you can see, as the video gets longer, the attention slice gets even bigger, dominating the total computational cost. Okay, so now that we know attention is the bottleneck, this figure shows the clever solution, the DraftAttention pipeline. It all starts with the video frames on the left. The model generates what are called a query and a key from the video data. You can think of a query as the model asking what to focus on, and the keys are like labels on all the video's information. Instead of comparing the full high-res versions, which is slow, it first creates a tiny low-resolution draft of the query and key using average pooling, which basically just simplifies the data. This draft then acts like a spotlight, guiding the full-res calculation to only focus on the most important parts, making the whole process much faster. So that pipeline we just saw is the theory, and these charts show the real-world results. We're looking at latency, or the total time in seconds to generate a video, for two different models, WAN 2.1 and Hunyuan. The key here is the sparsity ratio along the bottom. This is the percentage of attention calculations the model gets to skip because the draft guide deemed them unimportant. As you'd expect, the more you skip, the faster it gets. For the Hunyuan model, a 90% sparsity ratio results in a 1.75 times speedup, a massive gain, all without any retraining. Alright, so we've seen it's much faster, but the big question is always about quality. Does skipping 90% of those calculations hurt the final video? This figure gives us a clear visual answer. For each prompt, we see 3 rows of generated frames. The dense row is the original slow model. The SVG row is a competing speedup method, and ours is the new DraftAttention. Looking at the red boxes, you can see the SVG method creates a lot of distortion and visual artifacts. But our method looks almost identical to the high-quality dense version, proving we get that massive speedup without sacrificing the final look. To wrap things up, DraftAttention is a really elegant solution to a major bottleneck in video diffusion models. By using a clever low-resolution guide, it dramatically speeds up the generation process. We saw up to a 1.75 times speedup without sacrificing the visual quality that makes these models so impressive. This work makes high-quality video generation more efficient and accessible, which is a huge step forward. Thanks for tuning in to this week's AI Research Roundup. I'm your host, Alex.